All right. So we got a few kind of important things, and some of you may like some of these items, or at least the first one. I have extra credit homework assignment. It's called transfer. It has a lot of stuff that you need anyway to study for the final exam. So I don't think this is going to be an assignment where it's just busy work and a waste of your time. When you do this homework assignment, you'll be actually studying for the final exam too. And many of those items or concepts that you need for the final exam, and also this one, we'll talk about it today as our practice final exam. So that means you get multiple chances to practice and prepare for the final exam. And this will also count as extra credit homework assignment, which means the point values of this assignment is not added to the baseline, the denominator. It will only be added to the numerator when I compute the ratio of percentage that you get. Okay? If you already have 100% with your homework assignment, I think it can bump over the 100%. So you can have more than 20% of your final grade determined by your assignments. Yeah, that kind of zaps me a little. My cat is the other one. My cat also zaps a lot. When I pet my cat, the two of us would go like twitch. Both the cat and me. All right.
That funkier subroutine is due Tuesday?
On Tuesday, right?
Oh, cool.
Yep. Yep, and this one is due on Thursday, which is right before the final exam at 10:15. Yeah, because I think doing this homework assignment after the final exam is not going to be as helpful. So you definitely want to do it before the final exam as a process of studying for the exam. All right. So let's go to the practice exam stuff. And does anyone have any objection that we end the class earlier today if we can finish this stuff early?
Sure.
You should go
No
over
objection?
the news. You should go over the news that you posted.
New stuff?
Yeah.
I haven't really posted anything any news items because I have to deal with a few other, unforeseen stuff.
With the new screen that came out, that's secret. It's almost all over Yahoo.
What was that again?
New computer screen came out. It's literally see through the computer.
Oh.
And you walk around, it's like a little mirror basically, or like a little window.
Huh.
And it displays everything.
Is that what?
Sorry?
The computer screen that they have on Avatar.
Oh. I haven't even seen that movie yet. I'm sorry.
Did you see the news?
I didn't see it, but I know what they're talking about. I've seen other ones before. I don't know what article you're referring to.
Okay, because it was on top Yahoo page, so go ahead.
See-through.
All right.
It's like 40%.
All right. So here we have our first question for our practice final exam. And just like your first and the second exam, these are actual questions that I used in previous years. So we are not talking about watered down questions. This is pretty much the difficulty level that you can kind of expect, for your own exam. All right. So this is, one, pretty simple subroutine, and I think I have a trace already, have the precondition done. So let's go ahead and split the screen or have a new window so that we can look at the trace and also the algorithm at the same time. Now, before you trace anything, it is always a good idea to go over the algorithm quickly and make sure that you understand what the algorithm needs to do. In other words, you want to look at each and every single line and say, I know what this does, and so on. So we have a subroutine, which we have already used a lot in this class. Passing by reference, A is an array of integers. Now this is something that we have not talked about in this class. We talked about passing by reference, we talked about arrays, but we have not talked about how to pass an array by reference. Okay, so it's a combination of those two concepts, and after I give you this trace, the result of this trace, you guys would just go like, oh, okay, that seems to make sense. Okay. We have passing by value I. We have conditional statements.
Is this
Okay.
gonna be on the final?
Sorry?
Is this gonna be on the final?
Yes. It'll be in the final, and that's why all 4 examples, including and also your extra credit homework assignment, will also involve passing by reference, but with an array. So in this case, we have a conditional statement. Inside the conditional statement, we have return statements, and each return statement also has an invoke inside it. But this is not nearly as complicated as the Fibonacci number subroutine, because there's only one invoke. You don't have to deal with 2 invokes on the same line. And then the result of the invoke will be printed here, which is something that we already know how to do. So let's go ahead and trace this program. For the most part, I think it should be, yeah, I did it again. I resized it using the wrong control. All right, so let's go ahead and trace this algorithm. And in the question itself, X, Y, Z are based on your social security number. So what I will do here is to assign some random number to X, Y, and Z. So I'll change these to 4, 1, and 8. First line is line 10 because it is the first line outside of the definition of any subroutine. Is that good enough, or do you want it to be a little bigger? Bigger. Okay. Is that good, or a little bigger?
Yeah.
That's good? Okay. All right, so on line 10, we have to invoke the subroutine because I don't know what to print unless I'm done with invoking the subroutine and have the return value available to me. So that means I have to allocate columns for invoking evo. And the first thing we need to do is to determine, do we want a return line number or a return info column? It's going to be a return info column because the subroutine returns a value, and after the subroutine returns, there are more things to do on that line. So both of those are reasons why we need a return info. The return info needs to indicate which line we're getting back to, which is line 10, but it also needs to indicate what else do we have to do with the return value of that subroutine. Are we doing okay so far at this point? Okay. And I'll just go ahead and move it a little bit so I can have more room. The next thing we have to do is to set up columns for our parameters as well as our local variables, if any. In this case, we have only 2 parameters. The first parameter is A, and the second parameter is I. I is the easy one because it is passed by value. If it is passed by value, you evaluate the expression on the left-hand side of the right arrow. In this case, it's bar B bar minus 1. Bar B bar is 3 because array B has 3 elements. 3 minus 1 is 2, and that's why we use 2 to specify parameter I. That's an easy one. This is the big question because up to this point, we have never seen anything that combines arrays with passing by reference. But the concept still applies. In other words, instead of giving the subroutine a call number to find a single variable, now we are giving the subroutine a call number to find multiple columns because an array has multiple columns. So that means all we have to do is to change A to AKA instead of a single column. We say it is AKA also known as column C to column E. So when you pass by reference, when you pass an array by reference, it only takes up 1 column. The parameter takes up only 1 column, and it is still a reference to the original item. In this case, array B is living in column C to column E, and that's why parameter A, which is a reference to the same thing, only needs to say that it is also known as column C to column E. Is that part okay? Are there any questions about how to pass an array by reference? Okay. If there are no questions, we go into the subroutine. The first line is line 4. Line 4 needs to evaluate a condition. That's really quite simple because we only have to determine whether I is 0 or not. In the final exam, I will not explain what this operator means because it is in the notes already. And just to remind you, the final exam is just like the other 2 exams. It is done on paper. It's open book and open notes as well. You can print out anything and write anything prior to the exam and bring it to the exam. Any questions about what you are allowed to bring to the exam? Okay, but no cell phones. Okay, you cannot use your cell phone even as a calculator. I will try to make sure that all the divisions can be done by hand. Single digit. Okay. All right. So at this point, we have to say, we have to say I is different from 0 is false. Because I has a value of 2, it is different from 0. Oh, it's true. Never mind. You can always, yeah, I'm not going to go there because you cannot do it in the exam. I was about to say use a formula in, a spreadsheet to help you calculate the result. Okay, so now that we know this is true, we have to execute line 5. Line 5 is a return statement, but I cannot execute the return part until I'm done with the addition part, but I can't get done with the addition part until I'm done with the multiplication part, and I cannot do the multiplication until I know what this invoke is returning. So that means I have to invoke evo again with different parameters. Let me click on this one here. So this time, the only difference is I minus 1 is going to be passed to parameter I, but everything else are pretty much the same. Are there any questions at this point? Now we are also using the same convention as in all of your math and science classes, where multiplication has to be done first before addition and subtraction. So when you see multiplication and division, and also addition and subtraction without explicit parentheses, you have to perform multiplication and division first, and then use that result to finish your addition and subtraction. Is that okay so far? Okay. Because sometimes I get questions about that, and so people submit the wrong answer, and then later on they explain, I did not know the priority of the operators, and that's the convention that we use in most classes. Yep.
What's the priority?
Priority means, the order,
No,
when
I mean, you said multiplication, division, and then addition. Then
you
subtraction.
perform multiplication and division first, and then you perform addition and subtraction. We'll see. This is a good example right here.
Left to right, if all others are the same.
Yes.
Just like normal math.
It really, yeah, just like normal math. Okay, so now we have to set up our own return info, and we have to go back to line 5. The portion of line 5 that we have to finish is return a bracket I plus 3 times, and then the question mark, because we are replacing the invocation with a single question mark. In this case, the invocation is basically the last portion. Yep.
A bracket I in this sense is still referring to the A defined by aka column C through E.
Yes. But we don't care about that until we come back to line 5 and finish up the operation. In other words, the return info here may even contain syntax errors or other types of problems, but we don't care because we cannot do anything or check anything else until we know the return value of invoking evo again. So at this point, don't even worry about which I or which array A we're dealing with. All you have to do is to remember we are trying to resolve the return value of the subroutine, and we don't care about anything else at this point. There was another hand. Any other questions? Okay. So now we have to set up the other parameters. The first one is array A, or array A that is passed by reference. It's the same thing. It is still an alias of column C to column E.
Wouldn't it be referring to the previous column?
Nope, because we cannot have a reference to another reference. Remember, even with a single variable, we cannot have a aka back to another aka. So that means all the parameters passed by reference, they all must point all the way back to the original item. and not point to another reference. The programming language does not have the capability to chain references. So you cannot say this is a reference to that, that's a reference to that, and then follow the chain. They all have to be references to the original item.
Okay.
Yep.
I may not be seeing this, but columns C through E make references to the B arrays. There's nothing in column C through E that says A.
That is correct. A is nothing more than, okay, remember passing by reference is like a little slip of paper with a call number of something on it. So that little slip of paper has a name of A, and that's your parameter A. AKA column C to column E is the actual call number, and the book is column C to column E. In other words, if you think about this carefully, B, which is a name of those three columns, is just another name of column C to column E. We actually, we treat B and A in this case pretty much the same way. They are both ways to refer back to column C to column E. Is that okay? All right. And we also need to set up one more thing, which is our parameter I. Now, parameter I in this case is specified by I minus 1. The I minus 1, or the I of the I minus 1, refers to column H, which is 2. 2 minus 1 is 1. So that means this I here has a value of 1. And now we are done with the second invocation of evo. Okay. Are there any questions about how we set up the columns on line 5 or row 7 of the trace? Okay. No questions? We move on. And when we move on, we have to continue execution in the subroutine back to the first line, which is line 4. I is different from 0 is true because I has a value of 1. So once again, we go to line 5. And by now, we know that it's going to be about the same except for parameter I. So what I'll do is I'll just be a little bit lazy and copy and paste it and just change parameter I so that it is 0 instead of 1.
So you're making one more, right?
Mm-hmm.
Because I is still there.
You okay?
Yeah.
All right. So once we set up the columns, this time columns L to column N, we continue execution in the subroutine again, starting on line 4. Line 4 is still checking whether I is different from 0, but now that I is actually 0, I is different from 0 is false. Then we have to go to the else portion, which is on line 7. Line 7 says return A bracket I. So this is also a very important moment because we have to think, okay, so what are we going to do? Well, first of all, since it mentions A bracket I, we have to find out what A is. Parameter A is also known as column C to column E. Column C to column E is an array of 3 items. Is that right? And we want to address, or we want to access A bracket I, and I is 0. So that means we want to access the first element of the array referred to by parameter A. Is that making any sense? Okay. Well, when we look at this array, which is column C to column E, the first element, which is B bracket 0, which is also just column C, has a value of 4. So that means we are returning 4 at this point. Is that any questions at this point? Okay. All right. So when we execute line 7, we are returning 4. So what do we do when we execute a return statement? There's only one thing. Well, procedurally there are 2 things to do, but conceptually there's only one thing to do.
We have to copy the return info statement and replace the question mark with the value.
Exactly. And this time we're replacing it with 4. That's it. Now I know that many of you will say, oh, I know what is 3 times 4. I'll just change this to 12. That will get points deducted because you do not evaluate the expression until you get back to line 5. Okay, is that okay? Does everybody understand what I just said? Yep.
Like going back to line 11, how'd you get I equals 0? Or I-
Because every time I pass I to the next invocation, I subtract 1 from it. So it started off with 3, and then 2, and then 1, and then this time it got down to 0. Okay, but getting back to this part here, we do not simplify 3 times 4 is 12 at this point. We leave it just the way it is because it is not the time yet to evaluate line 5. Is that okay? Okay. Now you guys have the benefit of earlier classes that I have taught in previous semesters, so I can point out all the common mistakes that people make when they see something like this. Do not simplify anything. A bracket I is just A bracket I. Don't simplify that to a single value. 3 times 4 is just 3 times 4. Do not simplify it at this point. After line 7, we get out of the conditional statement. We end up on line 9. Line 9 is the end of the entire subroutine. There are 2 things to do, conceptually and also procedurally. So the first thing we want to do is to look up return info. It tells us we have to get back to line 5. Right? So now we can know we have to continue on line 5. The second thing we have to do is to deallocate all the columns that we allocated for this invocation. Now, this is also important because we have only one subroutine here, but the same subroutine has multiple invocations. This is actually the 4th invocation of this subroutine. The third invocation of the same subroutine. Are there any questions? So when you count the number of subroutines, this is what we call a source code. This is something that is specified in the source code. But when you count the number of invocations, it's called a runtime thing. Okay, because you can only determine how many invocations you will need when you actually run the algorithm. Is that okay so far? Okay. Now we are back to line 5. Line 5 becomes something like this. Return A bracket I plus 3 times 4. This is a good time to evaluate that whole expression. It doesn't have any more invokes. So now it is a good time to say, oh, okay, we are adding 12 to the value of A bracket I, and then we return the sum of that. But when we look at A bracket I, we are not looking at I, which is column N in this case, because this column is already deallocated. So when we execute this code, now this is where it gets a little bit more confusing, and it's probably a good idea to make this a little bigger so I can show just enough of the screen to demonstrate it. When we execute line 5 of row 15 of the trace, we are executing this particular statement, but using the context of column I to column K. So that means when we refer to A bracket I, we are referring to A bracket 1. So we are actually trying to calculate the sum of A bracket 1 and 12. A bracket 1, A is also known as column C to column E, and we're referring to the second element because A bracket 1 refers to the second element of the array. The second element has a value of 1, so now we're actually calculating 1 plus 12, which is 13. In other words, we are now executing return 13. When you execute return 13, you copy and paste the return info cell, you change the question mark to the value that you're returning, which in this case is 13, and you're done. Is that okay? So if I want to draw a picture, then I'm basically saying that this value comes from evaluating or executing this statement. So to draw, I don't know how well this works. So let's say area has no color. Transparent? No, you can actually just turn off the color too, I think. Right here. There you go. Then you can point. I'll just do it once. Because the other two instances would be pretty much the same thing. In other words, you evaluate or you execute this return statement to get to this 13 here. But this A bracket I, or this I here, comes from this I, which is column K. So I will also add this one single line here. And in case somebody is curious, yes, I do design circuit boards. So.
That drawing utility for it.
Hmm?
I hope you don't use that drawing utility for it.
We have two layers, right? The top layer and the bottom layer. Okay, so is everybody getting what these arrows mean? When we evaluate, when we execute this statement in L13, we are referring to the I as in column K. Once we understand or once we have computed what to return, we use that value to replace the question mark of column I. Is that okay? Because it can get confusing, but but it is important to understand how we get to this part here. All right, the return statement is all done. After line 5, we get out of the conditional statement. We end up on line 9. Once again, on line 9, we have two things to do. One is to recall which line we have to go back to. According to this, we have to go back to line 5. And then the second thing we have to do is to deallocate the 3 columns that we allocated for this particular invocation. And then we are done. Now we are back to line 5 again. But this time on line 5, I'll let you guys determine what we should be doing, what we should return, and what we should change when we execute line 5 this time. We are executing this statement, but using the context of column H. Yep.
That's what I was gonna say, we had to use I as 2, right?
So I has a value of 2 at this point, correct. In other words, we are evaluating A bracket I as A bracket 2, which is the third element of the array referred to by parameter A. The array referred to parameter A has column C, D, and E. The third element has a value of 8. So this is 8 plus 3 times 13. 3 times 13 is 39. 39 plus 8 is 47. Okay, so we are actually saying return 47. When we execute return 47, we are going to look up the return info cell, copy and paste it, change the question mark to 47, and do not do anything beyond this. After line 5, we get to line 9. Line 9 is going to do the same thing as usual. First of all, we have to find out where we are going to continue execution. This time it's line 10 because this is the first invocation on our way into the algorithm. So it's the last one on our way out of the algorithm. And the second thing we have to do is to deallocate all the columns that we allocated earlier. And then we continue execution on line 10. But line 10 now looks like this. We know exactly what value we are supposed to print. So then we just say print 47, and we're done. Are there any questions? Oh, and opposed. To indicate that we do not have anything else to do, and that's the end of this algorithm. Are there any questions? No questions? Let me save this in today's folder. Ah, no.
That's true.
And I'll just call it the same name as in the original question. Okay, any questions? Because I can hear some discussions amongst yourselves, so let's hear the questions. No questions?
So
Yep, go ahead.
turn, as you're getting out of the invoke,
Mm-hmm. Which, can you refer to the row number of the trace?
I don't know, I was just coming up with a question.
Okay.
But when you return the evoke, it
Mhm.
doesn't get evaluated until it's out of the evoke,
Correct.
whatever's being evaluated.
Correct. The first time we did this, was when I actually drew a picture. So let's go back to this moment. Let's go back to the moment. Well, there are two moments that are important. Row 13 is important. Row 13 is the moment where we executed return A bracket I. Okay? When we execute return A bracket I at this point, I, which is over here, has a value of 0. So A bracket I is the same as A bracket 0, which means I want the first element of the array referred to by parameter A. A is referring to columns C, D, and E, and we cannot see the values at this point, but the first element has a value of 4. So A bracket I becomes 4, and that's why it is returning A bracket I is the same as return 4. When you execute return 4, you copy and paste the return info cell and change the question mark to a 4. And that's all you have to do when you execute a return statement. The fact that the return info cell itself is also a return statement is completely irrelevant. Okay, it can be a return statement, can be an invoke statement, can be an assignment statement, can be a part of a conditional statement. It does not matter because you are just looking for that one single question mark, change it, and you're done with the return statement. So row 13 is important that you do not simplify this to 12. Okay, we do not evaluate anything other than just changing the question mark. So that's one important moment. The next important moment is when we actually execute line 5 at line 15, row 15 of the trace. When we actually execute line 5, row 15 of the trace, we are executing the statement as specified by the cell L13 here. Okay, so L13 is the statement that we're executing. So only at that point you should evaluate and say, oh, 3 times 4 is what we need to do first, and that's 12. And then you have to add the value of A bracket I to it. But at that point, the I, which is column N, is already gone. So I must be referring to column K, which has a value of 1. So you are actually executing return A bracket 1 plus 12. Is that okay? A bracket 1 refers to the second element of the array, which has a value of 1. So the whole thing becomes return 1 plus 12. 1 plus 12 is 13. So you're executing return 13. When you execute return 13 on line 5, row 15 of the trace, you have to find the question mark in the return info cell, copy and paste the whole thing, change the question mark to the value that you're returning, and that's it. That's where you stop. I know you already know 3 times 13 is 39, but we don't care at that point. Okay?
So this is just when you put the AK in column C3, it's just like another wormhole to
Yes.
the B, right?
Exactly. Instead of a single call number on a slip of paper to refer to a single book, you're referring to a section of books on the shelf. But it's the same mechanism. You still only have one little slip of paper, except on that slip of paper, you're not specifying a single call number. You're specifying a range of call numbers. Yeah, a shelf, a section, and so on. Okay. Any questions about this one? Yep.
So basically, you just times it and add the next one, and times that, add the next one as you come back.
The important part is when do you execute this statement. It is fully specified by the time we get to row 13, but it is not executed. We do not execute this statement until we get to row 15 of the trace.
When I is 2, and thus you add 8.
When I becomes 1 again. Remember, I drew this line to show you that when you execute this statement, we are using the I of column K and not the I of column N.
So how do you get 39 plus 8? Because B.
39 plus 8 is back here. Now, when we execute this return statement, all we do is to resolve the question mark of I 8 to 13. But we do not do any evaluation beyond that. So your question, what you're asking is, how do we know we are replacing this question mark with 47?
Because,
That's because when we execute this one, which is row 17 of the trace, the I is now 2. And that's 8.
that's what I'm asking, yeah, okay.
So it becomes 8 plus 39, which is 47. So we are basically saying return 47. When you execute return 47, you find the return info cell, you copy and paste it, and then you change the question mark to 47, which is the value that we are returning.
Yeah, that's what I'm getting at, yeah, okay.
Okay? So this one is definitely, I don't think it's any more complicated than, say, the Fibonacci number. The only thing that makes this one, different is that we are passing an array by reference. But everything else on this one you have seen already. Okay? So let's get this one out. And we'll move on to the next one. You can see I name all the questions after cars. Cars in a specific anime, to be exact. All right, so now we have MR2, and in this case, you can see it has pretty much the same thing. It's just the algorithm is different, but we have almost exactly the same kind of stuff here. The subroutine MR2 is the only subroutine, and what it does is it has a parameter A again, passed by reference using an entire array, passed by value I, passed by value K. We have a conditional statement, just like with the previous example. It tests for a condition. If the condition is false, is true, you basically do a recursion because we have to invoke MR2 again. If the condition is false, then we just return a constant of false. And every time we invoke it again, instead of subtracting 1 from I, I'm adding 1 to I. But you can see how this works because as I becomes larger and larger, at some point it's not going to be less than bar A bar anymore. Then it has to trigger the else part, and then it will stop the recursion. In the main subroutine, we have something different here. We basically, based on the return value of invoke, we have 2 different messages to print. Okay, so let's go ahead and trace this algorithm. Are there any general questions about the algorithm itself? This one will take a little bit longer because it has more items. So what I'll do is I'm just going to make this a little bit shorter. So I will go ahead and delete this column so that it doesn't take as much time. Question?
Yeah, what are they supposed to do like the other ones did a Fibonacci number? Does this do any?
Well, when we trace it, you will probably find out or realize what it does. So
Okay.
we'll defer this a little bit until we get to that part. Magnify this a little bit. Okay. The first line that we can execute is line 11. Okay, same thing. So I'm not going to repeat all the same stuff again. I'm just going to shortcut a little bit of this. The if is not done yet because I don't know whether it is true or not. Are there any questions at this point about this particular return info? Did I do anything differently compared to all the previous examples of invoking?
Just was just in there. That's it.
What it is in does not matter.
Yeah, that's it. That's about it.
It does not matter because my only job, the only thing I have to do at this point is to replace the invoke with a single question mark. Everything else on that line, I'm not ready to execute it anyway, so it doesn't even matter what it is. Then we have the set of the parameters. We have parameter A, parameter I, and parameter K. K is easy, it's just a constant. I is just a constant of 0. Parameter A is a reference to an array. In this case, it's a reference to array B. And once again, it is just an alias of column C to column E, because B is also from column C to column E this time, just like last time. So now we have set up all the columns. We are ready to go into the subroutine and continue execution. In the subroutine, we start with line 5. Line 5 is evaluating the condition. Is I I is less than bar A bar, is that true or false? It is true because bar A bar, which is the same as bar B bar in this case, is 3. 3 is greater than 0 is true. So now we move on to line 6. Line 6 is the recursion. And this time we do exactly the same thing as we usually do. We basically say return info is going to specify. We go back to line 6, and the return is not done. The first comparison is not done, and the OR is not done. We have to finish the invoke first. Okay? Now, for those of you who think, well, but this is an OR, we should be doing a short-circuited evaluation, that's fine. Okay, you can go ahead and do that, which means in this particular case, you can specify A bracket I equals K is false, so it becomes F or something. In fact, that would be the correct thing to do. Okay, so let me just, I'll explain exactly what I meant by that. You have to go back to line 6. The return is not done, but the first expression is done in this case because we have to do short-circuited evaluation. Okay, so you have to evaluate A bracket I equals K first. K is 5, I is 0. A bracket I refers to the first element of the array referred to by A. It has a value of 2. 2 equals 5 is false. So now you have to specify line 6, or the return info becomes return false. Am I done? Can I just say that the whole expression is false? No, because it is a disjunction. If one side is false, it does not mean the whole thing is automatically false. So that means I am forced to have to evaluate the right-hand side. But the right-hand side is an invocation. I'll just replace it with a single question mark. Yep.
Is line 5 for trace? Is there a comment section to let us not scroll all the way over? Oh, okay.
Yep. But not for line 6, because line 6, even though there's an evaluation of a condition, it doesn't change the flow of the program. Okay. All right. So that means we have to finish up the rest. So we have to do the actual invocation of MR2. So now we have to specify parameter A, I, and K. K never changes. We always pass K to K. So we know that this is just going to be 5. I gets incremented by 1 each time. So this time it becomes 1. And A also does not change. It is always a reference to column C to column E. Okay. And let me split the screen. Do this part first. And then scroll this back here. All right. All right, so now that we are done with setting up all the columns, we go back to line 5, which is the first line in the subroutine. We evaluate this expression again. I is less than bar A bar. It's still true because I has a value of 1 at this point. And 1 is less than 3 is true. Then we move on to line 6. When we look at line 6, we do not automatically say that we have to invoke. We first have to say, what is the result of A bracket I equals K? I is 1 in this case, which means we are trying to access the second element of the array referred to by parameter A. The second element of that array has a value of 6. 6 equals 5 is false. So that means we have to evaluate the invoke in this case. So I'm just being lazy by copying and pasting. You cannot do this, unfortunately, because we are not taking the exam in the lab. We are taking the exam in the classroom. So you will have to do it the long way. All right.
I have a question. On line 6 on the actual code is the value of K, K gets K?
Yep, K gets K. I'll explain what the algorithm is actually doing when we are all done here. All right, so now we still have I is less than bar A bar. It is still true because I has a value of 2, bar A bar is 3, 2 is less than 3 is true. Okay, and we are going to line 6. Now this time you have to be very careful because remember, we have to evaluate the disjunction on line 6 from left to right using the short-circuited type of evaluation. So now we don't have a choice. We have to say A bracket I equals K is what?
True.
Yep, K is 5, I is 2. We are accessing the third element of the array referred to by parameter A. It has a value of 5. 5 equals 5 is true. And if I know the left-hand side is true, do I know the expression, the result of the entire disjunction? Yes, we do. So the short circuit actually works in this case. We are now short-circuited, which means line 6 is now reduced to a single return true. Okay, we do not do any recursion at this point. We are all done with recursing. So we are now executing return true. When we execute return true, we take the return info cell, we copy and paste it, and then we just change the question mark to true. Because we are returning a value of true, and this is the result of executing return true. It just so happens that the return info cell also specifies a return statement. So don't let that confuse you. Okay? When you execute a return statement, you just change the question mark to whatever value you're specifying. The fact that it is also a return statement does not matter at all. And do not simplify false or true is true at this point, because we are not at that point yet. After line 6, we get out of the conditional statement at the end of the subroutine. 2 things to do. We have to go back to line 6 as per the return info cell. Second thing to do is to deallocate all these columns. 4 columns in this case. And now our context is switched back to this context. And we don't really need the program at this point, at least for a while. So I'm just going to make this portion bigger. Now we are back to line 6. But line 6 looks like this now. We have just resolved what line 6 should look like. Return false or true. Do we know what is the result of false or true?
True.
It is just true, so that means we know we are executing return true at this point. When you execute a return statement, once again, locate return info, copy and paste it, and just change the question mark to whatever value that you're returning. In this case, it is true. But do not simplify false or true is true at this point. It's not the time to evaluate it yet. Then we get to line 10. Line 10 is going to do the same thing as last time. First of all, we have to know that we are returning to line 6. Fine, we're going back to line 6. Second thing is column J to column M are now deallocated. Ah, no. Yeah, there we go. And now we're back to line 6. But when we're back to line 6, it is now looking like more like this because we have just resolved the invocation. Return false or true again. False or true is true, so we are just saying return true. When you execute return true, you locate the return info cell, copy and paste, change the question mark to whatever value that we are returning, which is true in this case, and you're done. Move on to line 10. Line 10 has 2 things to do. One is to figure out where we're going next, which is line 11. And the second thing is to deallocate the 4 columns that we allocated for this invocation. So we go here, do a strike through, and now we are continuing execution on line 11. But line 11 looks more like this now. If true, then blah, blah, blah. So do we know where to go next? Now, the first thing is you have to say true is true because it is a conditional statement. I know it looks kind of dumb, but it is kind of dumb, but it does explain why we are going to line 12 instead of line 14. Okay? So now we go to line 12 because the condition of the conditional statement is true. So we just go ahead and print out, I think mid-engine in this case. We're done with line 12, and we get out of the conditional statement. We get to post. We are all done. Hi, Paul. Oh, it's all right. Christmas party?
Nah, lab's closing for them.
Oh, okay.
Yeah.
We're closing because we are hosting a Christmas party, right?
No, not today.
Not today.
We're closing
Oh,
for them.
okay. All right. So, are there any questions about this particular program? Are you guys getting bored because I really kept saying the same thing over and over again? No. You're not. Well, the good thing is it is being recorded, and I will upload, the video. So in case you want to kind of, it really is okay. When you review the video, don't just watch it, from front to back, because this, and in this particular program, row 13, and also row 15 are the most important ones. If you understand those two, then everything else should be relatively simple. So that's the second one. We are now moving on to the next car. It's an MX-5. It's my favorite.
That's all the parts.
Yeah. But the MX-5 only appeared in, I think, 2 or 3 episodes. So initial D.
So what was the point of that last algorithm? What was the point of the last one?
The last one?
Yeah, you said once you traced it, you'd say what the point of it was.
Oh, wait, hold on a second. I think I just did something. I saved it, but I did not save it to the folder that we have for today. So I have to make sure that I save it to the right folder. There we go. Otherwise.
And the other ones?
The other one is already saved at the right location. Yeah.
Because I will have to look over this at home.
Well, that's the intention. The intention is, we do it in the class, we log everything so that you can review it at home. But we are learning something new today, even though it is a pre-exam or practice exam. All right, let's look at this one here. This one looks kind of more nasty, doesn't it? It's longer, and there are 2 points of recursion. Yeah, I think it looks kind of nasty. And we're also starting with a pretty big number, 191, instead of something like 2 or 3. There are no arrays in this particular case, so this is strictly recursion, strictly passing by value. There's no pass by reference in this case. And we also have to deal with return values. So in many ways, in terms of the number of concepts that I'm testing you, this one is simpler. This one only has conditional statements, has the mod operator. No mod, just the floor. No, there's a mod, there's a floor. Passing by value, not even passing by reference. No local variables, no global variables, no arrays, and a single invoke on the line of return. So in many ways, I think this one is easier. And we'll go and find out what this one actually does. Oh, did anyone figure out what the previous one did? Because somebody asked me that question, and I deferred that question and said, well, let's trace it first, and then I'll let you guys decide, what the program actually does. This one here, all it does is to search for the value k in array A. And it returns whether that value is actually in the array or not. Now, the way it works is, I just clicked the wrong, there you go. So the way it works is, if I is less than bar A bar, it implies that I is still a valid index in the array. If I is still a valid index into that array, I will specify something like this, which means if this element that I am looking at is the value that we are looking for, which is k, then I know the answer already. Because somebody just asked me this question. Here is an array, or the reference to an array. This is the value I'm looking for, which is k. And this is the index that you specifically should be using to compare to k. Or this is the index of the element that you should be comparing. So if that particular element that I'm supposed to look at has the value k, I'm all done. I don't have to look at the rest of the array to say yes or true, because what I'm looking at is already that value. I can just reply to whoever asked me that question and say, yes, the value k is in the array. Yep.
So are you just saying in a bunch of numbers is 5?
As soon as it encounters 5, it will stop. Now, on the other hand, if the element that I'm supposed to look at does not have the value k, as lazy as I am, what I'll do is I'll just go ask the next person. I'll just pass everything along to the next person and say, okay, it's your job now. This is a reference to the array. This is the value that we are looking for, except with one little change. I'm already done with examining a bracket I, so the next person can start with a bracket I plus 1, right? So I'll just say, okay, but I'm looking at a bracket I could not find the value k. You will be looking at a bracket I plus 1 and beyond. So that person will do whatever that person has to do, recursion and whatnot. And then when that person comes back with an answer, I just have to pass it along to whoever asked me the question in the first place. If that person says, I cannot find the value k either, then I'll just say, well, since I cannot find it with the element that I looked at, you cannot find it with the rest of the array, I guess that element is not in the array. So I just reply back to whoever asked me the original question and say, no, I cannot find it. You do whatever you want to do with the result of that. So it really is just a search algorithm. It's a linear search algorithm, but disguised as a recursive subroutine. Is that okay? I mean, sort of.
Which would be more efficient, to use a recursive subroutine
or
to use, yes?
In terms of implementation, recursion is more costly with the C programming language. If it's a tail end recursion, which this one is, in some programming languages, it is just as efficient. So that's a good question. In general, if you're programming in C or anything that is a modern programming language, recursion is more costly at runtime.
So there would have to be a specific application for it.
There has to be, well, okay, to answer your question, you have to understand that recursion and iterative, which means just regular loops, they are equivalent in terms of their ability to express the logic of an algorithm. So that means given any loops, any iteration, I can turn it into a recursive way of doing things.
Correct.
Given any recursion, I can turn it back into a loop and use a loop instead to deal with it.
Right.
So the difference is some problems, the solution is inherently more clear when it is expressed as a recursive solution. Other problems, inherently they're more clear when you express it as a loop.
But for CPU costs, it is more likely that a loop would be more efficient.
The loop is always more efficient. Yep. But in some cases, to turn a recursive algorithm into a loop, you'll be paying a much higher price in terms of the complexity of the program, and therefore ways you can make mistakes when you code it in a non-recursive way. And that's why we still write recursive subroutines, because sometimes it's just a more elegant way to express the solution. Yep. Good question. All right, so we'll start to do this one a little bit faster than before, because this one has basically fewer concepts. So we have comments, line number. The precondition has nothing to say because we do not have any global variables. We start on line 18. We specify the return info cell. We print whatever the subroutine is returning. And then we have to deal with the actual invocation of MX5. MX5 requires two parameters. One is n. N starts with 191, and k starts with 1. Yep.
They didn't put the line number on column 4 or row 4. There's no line
Oh,
number.
that's right. We have to go back to line 4. Very good. No, we have to go back to the same line, which is line 8. In the assembly programming class, you can find out how you can change the line 18 to line 4, so your program will behave in a very erratic way. So some of you will see me again in CISP 310. I'm sorry, I'm the only one teaching that class. Not the only one in the district. You can take that class from other colleges. Okay, so after this, I go into the subroutine starting on line 4. Line 4 evaluates the condition, n is less than 10, and n is 191. 191 is less than 10 is false. Okay, so that skips a whole bunch of lines already, right? From line 4, we are skipping all the way to line 11. Correct?
Yep.
Because when this condition is not true, we skip everything inside the then, go to the else, and then start with the line after the else. So on line 11, we test something else. We say n mod 10 equals k is what? Well, first of all, what is n mod 10? N is 191. 191 mod
True.
10 is 1. Okay, 1 equals 1 is true, right? Okay, so now we move on to line 12. Line 12 is going to return, invoke mx5, blah, 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 blah. Okay, so we'll go ahead and deal with that. In the return info, we specify line 12, return whatever the subroutine returns plus 1. So don't forget the operation after the invoke of the subroutine. Then we have,
I have a question.
yes,
On, go back to like the left, towards the left. Okay, so when you were on line 4.
Row 4?
Yeah, line 4. And you
Line
said
4.
it was false. So, but if it was true, you would go to 5, right? Just making sure.
if it is true, we'll go to 5.
Okay,
Yes.
so it's false, you just go all the way to skip.
We'll get to that point.
And go to that.
Yeah, we'll get to that
Okay.
point. Okay, so we have to specify n in this case. It is the floor of n divided by 10. N was 191. N divided by 10 is 19.1. The floor of 19.1 is just 19. That's what we have when we invoke it again. And we split the screen. I guess we won't be getting out any earlier than usual today. Okay, now that we set up all the columns, we continue execution in the subroutine starting with line 4 again. N is less than 10 is false because n has a value of 19. So we skip all the way to line 11 again. Line 11 is saying, n mod 10 equals k is
False.
It's false because it is 9. N mod 10 is 9. 9 equals 1 is false. So this time we go to line 14. Oops. Line 14 is once again a recursion. So we have to specify the return info. In this case, it's line 14. Return whatever the subroutine is returning. We pass the floor of n divided by 10 to n. 19 divided by 10 is no. Is 1. Yep, so we have 1 here, and then k is still the same as before. It is just k. So now we specify that, okay? And then we go to line 4 again. We basically do the recursion, starting from the beginning of the subroutine again on line 4. N is less than 10 this time is true. So we go to line 5. Line 5 is saying n is different from k is false. So we go to line 8 instead. Line 8 returns 1. We copy and paste the return info cell, change the question mark to a 1. We are done with line 8. After line 8, we are done with the conditional statement that is nested inside. But since this is the only thing we have to do for the then portion, we're done with the entire conditional statement. We go all the way to line 17. We are done with the entire subroutine. First thing we have to do is to remember to go to line 14. Line 14 looks like this now. So now we execute line 14, which is return 1. Line 14 executes return 1. So that means we copy and paste this. Replace the question mark with 1, and we're done. Oh, yeah, okay. Deallocate. This is one thing that's easier to do when you have it on paper. You just go, yep. Yep.
When you end like that real fast, you just deallocate. If there's several that go all the way out, you just deallocate all of them in one
Everything
line.
in that invocation. everything in that invocation. So after line 14, we go all the way to line 17 at the end of the subroutine again. And then we have to remind ourselves to continue execution on line 12. And then we deallocate all the columns again. And line 12 now looks like this. It is time to actually execute line 12, which means return 1 plus 1 is now return 2. That means we have to look for the return info cell, copy and paste it, change the question mark to 2, but do not do any printing. And after line 12, we get all the way out to the end of the subroutine. Same thing. We have to remind ourselves to continue execution on line 18, deallocate the columns, and then continue execution on line 18. But line 18 is already fully resolved. I know what I'm supposed to print. Print the value of 2, and we're done. So in this case, it is looking at the decimal number, and it's trying to find the number of occurrences of as a particular digit. So if I were to change this 1 to 9, it would have printed 1, because there's only one 9 in the decimal number 191. You can change the number and change k and
so
see
if you changed k to like number 2,
then it would have printed 0.
That's awesome.
It would have printed 0 because n is different from k is always true. So this is, the last recursion would get that. And then the other ones, it will also be the same thing because n mod 10 is never going to be the same as k. So that means we'll never do the add one. So that means it would just go the 0 at the very end would just get passed in a chain all the way back to the print statement, and you'll just be printing a value of 0.
Okay. That's cool.
And that's why I named the files. Oh, I have to save it again to today's folder. And that's why I named the files under names that do not imply what the algorithm is supposed to do, because I don't want people to know what it is supposed to do.
Because very
and
simple.
just no, I just want people to follow the algorithm. So now we have RX7. Next time I have to specify, FC or FD.
Yeah.
Otherwise, it's not clear, right? At the MX5, we'll have to specify NA, NB, and now NC. But NC was never in the show, so we can ignore that. All right, last example. All right, so just a quick review of the algorithm itself, because we want to know is there anything that is really tricky. Well, let's take a look here. We have a subroutine. It has one single parameter passed by value, has a local variable r, and it has 2 consecutive conditional statements inside. One can potentially have a return. One always has a return. That could be a problem because that may not stop.
When you give it to the...
Oh, no, never mind. No, it has a return, which is fine. It's the invoke that will make it endless. Okay, so this is fine. Never mind. Okay, I panicked myself too early. Okay, so it really doesn't have anything that we don't know already. Has no arrays passed by reference, has no pass by reference whatsoever. So this one would be a quick one to go through. Comments, line number, no global variables. Okay, R is not global. R is a local variable, so we don't really have any global. So the precondition there's nothing to say. We execute line 15, but we don't know what we're supposed to print until we invoke the subroutine. So that means we have to invoke the subroutine first. The return info is just printing whatever it returns. Then we have to set up the parameter for invoking RX7. N has a value of 6 to begin with, and the local variable R has an unknown value to begin with. Typical stuff that we have seen already. Then we go to line 4. Line 4 evaluates the negation of n is less than 2. N is 6. 6 is less than 2 is false. Not false is true. So that means we have to go to line 5. Line 5 is going to do the recursion because we have to invoke RX7 in order to know what to use to change the value of R. So that means we have to specify return info. And when we're done, we get back to line 5. And when we get back to line 5, we just take whatever the value is and use it to update R. Okay? And then we specify N and R. Oops. R is always unknown because it's a local variable. And in this case, it's always done by division by 2 and then take the floor of that. 6 divided by 2 is 3. The floor of 3 is 3. So now we are done with that portion. Split the screen a little bit. There we go. And then we start from the beginning of the subroutine again, which is on line 4. And it's 3. 3 is less than 2 is false. Not false is true. We go to line 5 again. So recursion. This time n is the floor of 3 divided by 2. 3 divided by 2 is 1.5. The floor of 1.5 is 1. And we go back to line 4. Line 4 is evaluating the negation of n is less than 2. N is 1. 1 is less than 2 is true. Not true is false. So we no longer execute line 4. Instead, we execute line, well, we don't go to line 5 anymore. We go to line 7 in this case. So the recursion stops right here. There are no more invokes after this point. Line 7 just wants to do one thing with R. R gets a value of 0. Then we move on to line 9. Line 9 evaluates n mod 2 is different from 0. Well, what is n? N is 1. 1 mod 2 is 1. No. 1 mod 2 is the remainder of 1 divided by 2, which is 1. 1 is different from 0 is true. So we go to line 10. Line 10 is just returning R. R has a value of 0, so it's just returning 0. That means we copy and paste the return info cell, change the question mark to 0. It looks confusing, but don't let it confuse you, because all we do is to replace the question mark with something, but we don't do anything else on that line when we execute the return statement. Yep.
So after you're finished with the first if and else, you don't skip the second if and else?
Because they are consecutive. The second if is after the end if of the first one. So after you're done with the first conditional statement, then you do the second conditional statement. They are consecutive conditional statements, not nested.
Well, if there was another if and else together, then you would have done only one, right, or something like that?
No. You have to look at the structure of the code. In this case, these two are sequential. So when you're done with the first one, you always perform the second one. Okay. After line 10, we get out of the second conditional statement. We get all the way to the end of the subroutine. So at that point, we have to remind ourselves to go to line 5 and then deallocate the columns that we allocated. Like that. And now we are back to line 5. But when we got back to line 5 looks like this. R gets a value of 0. So R, in this case, column H, will now get a value of 0. We are done with line 5. There's nothing else in the first conditional statement. Now we go to line 9, which is the beginning of the second conditional statement. And in this case, it's 3. 3 mod 2 is 1. 1 is different from 0, is true again. So we move on to line 10. Line 10 returns R. R has a value of 0. So we take the return info cell, copy and paste it, and just change the question mark to 0 in this case. And we are done with the return statement. Then we get out of the conditional statement at the end of the subroutine. On line 14, we have two things to do. One is to remind ourselves that we have to continue execution on line 5. The second thing is to deallocate the 3 columns. And now we are back to line 5 again. But line 5 now looks like this. We are still assigning a 0 into R. So R in this case is column E. Column E gets a value of 0. After line 5, we get to the second conditional statement on line 9. Line 9 is saying what is n mod 2 is different from 0. N mod 2 in this case is 6 mod 2. 6 mod 2 is 0. 0 is different from 0 is false. So that means we have to go to line 12. Oops. Line 12 is going to execute return R plus 1. R is 0, R plus 1 is 1, so we are effectively executing return 1. Return 1 means we have to copy and paste the return info cell, change the question mark to the value that we are returning. In this case, it is 1. And we're done with line 12. After line 12, we get out of the second conditional statement. We get to the end of the entire subroutine. We have to remind ourselves to go to line 15, and then we deallocate the columns. And then on line 15, we execute the resolved line 15, which is printing a value of 1. And we are done. Post. Okay. So we have 30 seconds left. So I just have to remind you, how to get ready for the test. It is comprehensive, and you can see that we don't have any pre and post conditions. Is that good news or bad news?
Very good news.
No one is complaining? No one is going to go to the dean and say, but Tech promised that we will have pre and post conditions in the final exam, and he did not. No? Okay, so I'm safe. Yeah, we'll have 4 or 5 questions depending on the complexity, but they will have about this kind of complexity. Up to what we talk about today. Okay, but don't forget to study. I will not answer questions like what is mod, what is floor, and so on.
Make sure you save it. Make sure you save it.
Make sure I save it.
Yeah. Are you going to upload this on the website today?
I will do that as soon as I have a chance.
Okay.
So we just come on Thursday.
Thursday, no, 10:15. You have to be here 15 minutes earlier than usual. The exam starts at 10:15 and it ends at 12:15.
Oh, okay.
On Thursday, right?
On Thursday, next
Okay,
Thursday.
thank you.
Next Thursday, not any Thursday beyond that.
Okay.
I have to be a little clear. All right. Yes.
Can I get my